All right, we have got some end of the chapter practice problems to do with each other. So let's draw the Lewis symbol for each of the following: bromine and aluminum. Pause the video here. Hopefully for bromine, you drew the symbol and then saw that there was 7 electrons. So we did 1 on each side before doubling up. So there is one side of bromine that only has 1 dot. It doesn't matter if it's on the left or the right or the top or the bottom. Aluminum has 3. Again, it doesn't matter where those 3 are. It could be on the side and the bottom and the other side, as long as there are 3 lone dots. How about this one? Draw the Lewis symbol for phosphorus and for selenium. How did you do? Did you get these answers? Now draw the Lewis structures for the polyatomic ion NH2 with a -1 charge. Try drawing it with electron dots for one of your drawings, and for the second drawing, draw it with lines wherever those bonded pairs are. Did you get this for your first answer and this for the second answer? Let's do it together. Nitrogen, and there's 2 hydrogens, so I'm just going to put a hydrogen on one side and a hydrogen on the other side. Let's do our electron count. Nitrogen has 5 valence electrons. Each hydrogen has 1, so 1 times 2. So that would be 5, 6, 7, and we need to add, it's a -1 charge, so we need to add an extra electron. We need to show 8 electrons in this drawing. So I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8. This has a negative charge. Those are sharing and these are sharing. We can show that by drawing a line. Make sure that we have 2 sets of lone pairs of electrons around that nitrogen, and overall has a -1 charge. Try this one. Draw the Lewis structure of HCN, which has a triple bond. Draw one Lewis structure with electron dots and the other with lines. Let's see how you did. Here's the answer, but let's actually work through it. H, then C, then N. Let's do our electron count. Hydrogen has 1, carbon has 4, nitrogen has 5. 5 plus 4 is 9, plus 1 is 10 electrons. We have to show 10 electrons in this structure. So let's start with looking around carbon. Let's have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 8 around carbon. Carbon's happy. Hydrogen is happy because it has 2 to be like helium. But nitrogen is not happy. Nitrogen only has 1, 2, 3, 4. And we know everybody needs to have 8 to be happy. Now we were told that there was a triple bond. The triple bond cannot be between the carbon and hydrogen, because remember, hydrogen can only have a maximum of 2 electrons. So we can't have a triple bond with hydrogen. Let's see where we can get that triple bond from. We can take these 2 electrons and make a bond right here. So I'm going to redraw these 2 electron dots and make them like this. 1, 2, so that would be 1 bond. These 2 can go up and form a second bond. And these 2 can come down and share and form a third triple bond. Let's do some counting now. Carbon, if I redraw this, and it has that triple bond with nitrogen. Nitrogen has those electrons over there, and 1 bond with H. I'm going to draw little electrons on all of the ends of these bonds so we can do our counting. Carbon, let's make sure carbon is happy with 8. 2, 4, 6, 8. There you go. Carbon has 8. Let's look at nitrogen. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 with that triple bond. And let's make sure we have a total of 10. 2, 4, 6, 8, 10. There we go. Using the VSEPR theory, predict the shape of SCl2. Pause the video here and draw it out. All right, sulfur there's only 1 of, and chlorine there's 2 of. So let's just do S and Cl and Cl. So S is my central atom. Sulfur has 6 outermost electrons. Each chlorine has 7, so 7 times 2 is 14. 6 plus 14 is 20, so we have 20 electrons to draw. I'm going to start off by doing 8 around sulfur, so it's happy, 8, that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, it looks like there's all single bonds here, so I'm going to redraw those 2 electrons to make a bond there, and redraw these 2 electrons to make a bond there. Now it looks like, just the way that I drew it, this is a linear compound, but we can't just go off of what it looks like. We need to count how many things, or domains, are around my central atom. And in this case, there's 1, 2, 3, 4. There are 4 domains around the central atom. So if I were to go back and look at my cheat sheet, 4 things around my central atom means that it has an electron geometry of being tetrahedral. But then we have to see what shape is it really, how many bonded atoms are there, and how many lone pairs are there. Well, there was 2 chlorines and 2 lone pairs. So it is a bent shape. It will look like this. It would actually be in 3 dimensions. S with our 2 sets of lone pairs up here, and then a chlorine down here and a chlorine down here, and those chlorines would be surrounded by electrons. Why don't you pause the video here and predict the shape of the polyatomic NO3 with a -1 charge. Let's see how you did. NO3 with a -1 charge, so because there's 1 nitrogen and 3 oxygens, 1 nitrogen would be my central atom. Surrounded it with 3 oxygens. Let's do an electron count. Nitrogen has 5 valence electrons. Each oxygen has 6, so 6 times 3 is 18. Plus it has a -1 charge, so add an extra electron. We need to have 24 electrons around this compound. Let's start with drawing around our central atom and then fill in any blanks around those oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I can see right off the bat that I do have an issue. This oxygen does not have any electrons up there, and so if I were to look at this oxygen, it only has 2, 4, 6 electrons, and we know that we need to have 8. So we need to figure out how to remedy that and where we can share electrons to have 8, because this oxygen's happy at 8, this oxygen is happy at 8, this nitrogen is happy at 8, but this oxygen only has 6. So let's pull some electrons from, how about here? And we pull them over here to share with that oxygen. That would look like this. I'm going to take these 2 electrons and make a bond, and then these 2 electrons will come from up above and make a bond. So I'm going to scribble that out now since it went over there. Now this oxygen has 2, 4, 6, 8. Good. The nitrogen still has 2, 4, 6, 8. Now everybody's happy. Now let's figure out what shape it is. How many things are around my central atom? 1, 2, 3 things. So that would make it trigonal planar. And of those 3 things, they are all atoms. There's no lone pairs. So going back to my cheat sheet, there's my 3 electron groups. So its electron geometry is trigonal planar. But here is my 3 bonded atoms, no lone pairs. So its shape is actually trigonal planar as well. As you were drawing this, you might have put your double bond on a different oxygen, and that's okay. If you had your nitrogen double bonded to the right oxygen, that's all right. Or if you had your double bond going to the bottom nitrogen, that's okay too. It could look like any of these. As long as wherever that double bond is, there's only 2 lone pairs around that oxygen, because that would give it 8 total electrons. And then the rest of the oxygen that have the single bond would have 6 electrons around it. Why don't you pause the video here to predict the shape of these 2 compounds. Let's look at ClO2 with a -1 charge first. I did my electron count, 7 from the chlorine plus 6 times 2 is 12, plus 1 because it's a -1 charge, so 20 electrons for this compound. P is 5 electrons, 2 oxygens would be 12, and this is a +1 charge, so I have to subtract an electron, so we got 16 electrons for this compound. My central atom here is chlorine. My central atom here is P. Let's start with putting in our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, there's our 20 electrons. Everybody has 8 around it, so these are single bonds. Now let's look at our central atom. We have 1, 2, 3, 4 things coming off of it, so it's a tetrahedral electron geometry, and there are 2 atoms and 2 lone pairs. That will make this bent. And you could look at your cheat sheet to verify that. Let's look at our PO2 plus. We have 16 electrons for this guy. I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Currently, P is happy, having single bonds with both oxygen. This oxygen on the right is happy, it has 8, but the oxygen on the left only has 4. So we're going to need to do some sharing. Let's share 2 from this phosphorus to make a double bond there. That would give this oxygen 2 on the left, 4, 6. It needs 2 more, so we'll share this top P electrons to make a triple bond there. So we would have P single bonded to O, doesn't matter if it's the right O or the left O, and then it's triple bonded to the other O. Let's do our electron count. We need 16 again. 2, 4, 6, 8, 10, 12, 14, 16. Yep, we're good there. Now let's make sure everybody has 8. 2, 4, 6, 8. Good there. 2, 4, 6, 8. The P is good. And for my O, 2, and then 4, 6, 8 from those triple bonds. Everybody's happy. Let's look at the shape. My central atom only has 2 things around it. 1 oxygen, a second oxygen. There's no lone pairs. They're both atoms. This is a linear compound because there's 2 things around it and they're both atoms if you look at your cheat sheet. For this one, using electronegativity values, classify the bond between each as nonpolar covalent, polar covalent, or ionic, and label any polar covalent bonds with the slightly positive and slightly negative, and show the direction of the dipole. Let's look at the answers. In order to look at P and Cl, I got to look at those electronegativity values and subtract them. I would get a difference of 0.9, and chlorine is the larger electronegativity value, so we would point our arrow towards chlorine, and that would have my slightly negative end of the compound. For B, we've got bromine and bromine. Subtract the 2, we get 0, so it's nonpolar covalent. Sodium and oxygen. Sodium is a metal. It is an ionic compound. We could subtract those 2 values and see the difference is larger than that 1.8. And D, oxygen and iodine. Subtract the 2, and I get a difference of 1. It is polar covalent because that is greater than 0.4. And I would draw this as my arrow pointing towards the oxygen because it is a greater value. So it is my slightly negative end. The last batch of sample problems wants us to determine whether OF2 is polar or nonpolar. Why don't you draw that compound out? Let's look to see how you did. We had O and we had F2. So I drew mine out looking like this. There's only one O, so it's got to be the central atom. There are 6 electrons coming from oxygen, 7 from both of the fluorines, so that's 14. So we have 20 electrons to account for. I'm going to start going around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so it's a single bond between the oxygen and the fluorine. Now let's look and see how many things are around oxygen. There's 1, 2, 3, 4. 2 atoms, 2 lone pairs, so it's going to be bent like this. Now we need to subtract O and F. The difference between 3.5, oxygen is the 3.5, and the fluorine is the 4.0, is 0.5, which is greater than that 0.4 to be a nonpolar. So it is polar. We would show then arrows pointing towards the F's because the F's are the larger electronegativity values. Arrow towards the F, arrow towards the F. The F's are my slightly negative end. The oxygen is my slightly positive end, slightly negative end. And because it is bent, those dipoles do not cancel. So this is a polar molecule. Let's look at the last two. Determine whether PCl3 and Cl2 would be polar or nonpolar. Let's look at both of my drawings here. I added up my electrons for P, which would be 5 electrons, and 3 times 7 is 21, so there would be 26 electrons in PCl3. Here's my PCl3. My phosphorus is my central atom, so I put 8 around that first, and then filled in my 3 chlorines, and everybody has single bonds. So there's 1, 2, 3, 4 things around phosphorus, which is a tetrahedral electron geometry. 3 atoms and 1 lone pairs make this a trigonal pyramidal. And then I want to subtract my P and my Cl, which is 2.1 from P, and Cl is 3.0, so I subtract those two, that's 0.9. So each one of my P and Cl bonds is going to be a polar bond. My chlorines will be my slightly negative end. Slightly negative. My phosphorus will be my slightly positive end. So 3 arrows showing those polar bonds. If I look at chlorine, Cl2, each chlorine has 7 times 2, so that would be 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's a single bond between the two. Subtract 3.0 and 3.0, we get 0. That would be a nonpolar bond.